So in the last lecture, we understood that how to check the hypothesis testing uh, using the critical boundary method. Now, there are various ways to kind of calculate the same thing to get the critical values and all, and p-value is one of them. In fact, this is the most widely used method into the corporate world. What is this p-value? P-value is going to help you to measure the strength of your evidence in support of your null hypothesis. In other terms, you can also say that p-value is like a probability of your null hypothesis. Means this is an informal statement you can say about p-value, that if your probability is going to be higher, we will accept the null hypothesis. If the probability is going to be lower, then we are going to basically reject the null hypothesis. So we should not say accept the null hypothesis, means we will fail to accept or reject the null hypothesis. I'm really sorry about that. So that's basically will be the part what we do in p-value. Now, what is the lower p-value and what is the higher p-value? Now, as a thumb rule, we generally go with again 0.05. This is 5%. If it is lower or equal to this value, we generally say that, okay, this is going to be rejection of hypothesis testing, null hypothesis testing. So that is what basically we do. So if the p-value is less than this, then your significance level, which in this case is going to be like 0.05, then we're gonna reject our null hypothesis. So that is the part we do. So if you remember my last statement, which we have solved it with the help of the critical value method. So now we're going to solve the same problem by a different approach. So now let's say my mean value, again, this is my sigma which we have calculated for this. So sigma by root n, 90 by 16, we got 15. Now my mean was 350 and we got for 36 stores. So this was I think 36. So there's a mistake here. I can fix it. This should be 36. And we were getting like 370.16. This is the same example what we have seen. Now here what we're gonna do, we're gonna calculate our z-score. And if you remember from the standardization formula of z-score, it is x bar minus nu divided by sigma x. This should be sigma x, but that's okay. Now let's move on and see this. So this is going to be your sigma x. Okay. So now if I go here and plug in these values, so we got 370.16 minus 350 divided by 15 and we got 1.34. Now let's look at the corresponding value for it. 1.34, what is the corresponding value for it? So for this, let's go here and start checking this value. So 1.3 and we need to go for 4, right? So this is coming as 0.9099. Okay, so this is the value which we're gonna get for this. So we got 0.9099. So what is the next step? Now to calculate the p-value, we are gonna subtract it. So 1 minus whatever the value we got corresponding to the z-score table, we will get like 0.0901. Now since it's a two-tailed test, multiply it by 2. Remember when we were doing in the criticality test also, if we were saying like 5%, so we were dividing into 2.5, 2.5. Similarly here also, since the value is two-tailed, that's the reason we need to multiply by 2. If it is a one-tailed test, then in that case no need to multiply, it will remain the same. So if we're going to multiply, I got 18.02 means 0.1802, which is 18.02%. Now this value is definitely greater than 5%. So that means we will fail to reject our null hypothesis. So if you remember with the criticality portion also, we have exactly done the same steps. And here also we followed the same part to get this output. What if my z-score comes out to be negative? Now, in the last example, when I did all these calculations, my z-score value came out to be positive, which was 1.34. But what if this value comes out to be negative, let's say minus 3.02, then what you will do? In that case also, we can look at the z table and we will be having the z values for it if you want to go and check that. So here, if you go and check the values, there will be negative values as well. So from here, you can basically see the value of minus 3.02, which you will get this, let's say. Now, once you will get this value, so this will be a z table. Now, if you remember, if the z-score was positive, I was getting like 0.09 something, and we were subtracting it with 1 minus this and going with this. So if you remember, This was the part I'm saying. So here we were subtracting it with 1 minus this, right? But when the Z score was negative, we need not subtract it. We will just keep it the value as it is. And for one tail test, don't multiply by 2. For two tail test, multiply by 2. That will be the only difference. So this is how you can play with your p-value.